Hi, this is Todd with The Land of Math. In this video, we're going to talk about combining like terms. Anytime you're working with expressions or equations, one of the things you can do to make your life just a little bit easier is to combine like terms. So in this video, we're going to talk about what that is, and we'll give you a few examples to help you out. So all that's coming up next on The Land of Math. In this video, we're looking at combining like terms. Now, when we're talking about a term, we're basically talking with something that has like the same variable. So in this example here, we're going to use some money to, at least at first, kind of help us model this. You can see I have a pile of 2 pennies and 3 pennies. So I'm going to write this with a variable. So I'm going to make the left side 2p and the right side 3p. Obviously, I'm picking the letter p because it represents pennies. So if I combine those, and I can because they're all the same, they're all p's, I would have 5p. If I wanted to evaluate this or to solve it, I would just take 5 and I would replace the p with what it's worth, which is 1 cent. I multiply it, I would get 5 cents. So that's an example of combining like terms. Here's another one where we have all the same term or the same variable. So here I have 3 piles of dimes. So all I have is nothing but dimes. So I definitely can combine this. If I set it up so it looks like an expression, I would have 3d. Obviously, D represents dimes, plus 3D, plus 2D. Now, if I combine all those, I would have 8D. And the reason I can combine them is because they're all dimes. They're not like quarters or nickels snuck in here. Now, if we were to evaluate it and we didn't combine them, we didn't combine our like terms, what we would have is 3 times 10 hundredths, 3 times 10 hundredths, and 2 times 10 hundredths. And when we would actually multiply those, we'd get 30 cents plus 30 cents plus 20 cents. And we add those all up, we'd end up with 80 cents. But when we combine it, it makes it a lot easier. We would just substitute 10 cents for the D. It would be 8 times 10 cents, which would be 80 cents. You notice we get the same answer both ways. So next we're going to combine like terms, but this time we're going to have more than one variable. And you see here I have it appears 6 different piles of coins. We have some dimes, some quarters, some nickels, some pennies. If I'm going to write these so they each have a variable, so I'm basically just taking the first letter of the coin. So you'd have 2D plus 3Q plus 4D plus 5N for the nickels. Over here we'd have 2 quarters, so 2Q, and finally we'd have 4P for the 4 pennies. And so what we're going to do is we're going to combine or just add all these together. So I'm just going to combine all this stuff together. Now, obviously, I have some duplicates here. So if I was just taking my coins, I could just take all the dimes and put those together. I could do the same thing with my quarters. So I have 2 over there, 3 over here, put them all together. Now, you'll notice I have nickels, but there's only one pile of nickels. So I'm just going to keep them the same. And I'll do the same with the pennies because there was only one pile of pennies. Now, what I've just done is I've basically combined like terms. And if you look here, you can see there's 6 dimes, so 6D. There's 5 quarters, so 5Q. There's 5 nickels, so we're going to add 5N. And then finally we have 4 pennies left, so it'd be plus 4P. Now, what you really want to get to, so right here, this would be our simplified version. But what we want to be able to do is to do this without actually using coins. So let's go back to the original problem right here. And let's say we didn't have the benefit of the coins. What we could do is find like terms. So you can see I have D's here and here. So 2D plus 4D is 6D. Next I would look at the letter Q, or the variable Q. I have 3 Q's here, 2 Q's here. If I put those together, that would be 5Q. Next I would go and look at the N. So you can see it's a positive 5N, but there are no other N's. So I'm just going to leave it. So it'll just stay 5N. And then finally, the last thing we have left is the pennies. So plus 4P, I'm just going to leave it plus 4P. When you look at what we came up with when we combine like terms here, compared to what we did when we actually moved the coins together, it's the exact same thing. So let's say we want to evaluate this expression. So what I'm going to do in place of each of our variables is I'm going to put the value of the coins. So for D, which represents dimes, it would be 10 cents or 0.10. For quarters, it's 25 cents. For the nickels, it's 5 cents, written as 0.05. And of course, for the pennies, it would be 0.01. And all we're going to do is just multiply those together. So for the dimes, that would be valued at 60 cents. For the quarters, it would be $1.25. For the nickels, it would be 25 cents. So it would just be 0.25. And then finally, for our pennies, it would just be 4 times 1 cent. So it would be 4 cents or 0.04. And at this point, I just need to combine them together. When I combine the dimes and quarters, I have $1.85. When I go ahead and add the nickels to that, I end up with $2.10. And then I go ahead and add the 4 cents. So the total value of those coins would be $2.14. Our next example, we're going to look at when we're combining like terms with just one variable, but this time there's a subtraction. So here you see I have 5x plus 3x minus 4x. So they all have the same variable. So working left to right, I can combine my x's here. So 5x and 3x is 8x, and then it's going to be minus 4x. Well, we're going to take them away. So 8 minus 4 would be 4. So 8x minus 4x would be 4x. And that's how we would simplify that one right there. Next, we're going to combine like terms with more than one variable where we're also subtracting. So here you see this expression that we have. So we're not using coins this time. We're just going to go ahead and look for common terms. So the first one I'm looking at is y's. And I have a 12y, and then later I have minus 4y. Notice I'm using the subtraction sign or the minus sign in front of the 4. 12 minus 4 would be 8y. Next, we're going to look at the t's. I have a positive 3t, and there are no other t's. So I'm just going to keep the 3t. Next, we're going to look at x's. Here I have 9x plus 2x, and that's it. There's no other x's around. So if I combine 2x and 9x, that gives me 11x. So those two together combined equal 11x. And finally, I just have this number on the end with no variable. It's the only one left. So I'm just going to keep the plus 2. And so that's how we would simplify that expression. So here's another one. This time we actually have exponents and variables in here. So this one we're looking at, again, we're combining like terms. So I have a 5x and I have a 3x on the end. So 5x plus 3x, together those two would combine to equal 8x. Now next you're going to notice this 5x squared. I didn't combine with the other ones because I have the little square root or square sign on it. But later on there's another one, this 2x squared, that also is squared. So I can combine those two together to give me 7x squared. And finally this 4y, it's the only y, so I'm just going to keep it the way it is. All right, next. Here we're starting to get into negatives and exponents and subtracting the whole deal. So again, I like to start off with the first one. I have a negative 7y. So I want to look through here and see if there are any other terms that have just a y. So here we have one, minus 2y. So I have a negative 7 minus 2. Now when I do that, I actually get negative 9. So it's a negative 9y. On this next one, I'm looking at x's. Now it says minus x. What I like to do sometimes is just throw a little 1 in there. So I have a minus 1x. I have later a plus 4x. And at the very end, I have a minus 8x. So I have a lot of x's I can combine here. When I combine the negative 1 and a positive 5, so negative 1 plus 5 would equal 4. And then I would take the 4 and I would go minus 8, which would give me a negative 4. So when I combine all those x's together, I would end up with a negative 4x. The final thing we have left is this minus 21y squared. There are no other y's or y squared, or no other y squares, I should say. So we're just going to leave it alone. Well, hopefully this was somewhat helpful. We'd love it if you would subscribe and give it a thumbs up. And until next time, we'll see you on the Land of Math.